In this lecture, we'll cover the Lewis structures for more complex molecules and polyatomic ions. Let's begin. The way formulas are written can give us clues as to how the atoms are connected. For example, the formula of hydroxylamine, NH2OH, tells us that two hydrogens are attached to nitrogen and OH comes in as its own group. Since hydrogen is always a terminal atom, the hydroxide group, OH, is attached to nitrogen through the oxygen atom. The formula for ethanol drops similar hints. The CH3 tells us carbon is surrounded by three hydrogens. Then the next grouping, CH2, tells us the second carbon has two hydrogens attached and bonds to the OH group. Let's continue working with the ethanol formula to see if we can finish out the ethanol structure. Let's follow the same process as in the last lesson. 1. Sum up the valence electrons. We have two carbons with 4 electrons, one oxygen with 6 electrons, and 6 hydrogens bringing 1 electron each for a total of 20 valence electrons to place in this structure. 2. Select a central atom and arrange the other atoms around it. From the formula's clues, it's a safe bet to connect the two carbons and oxygen together, surrounded by the hydrogens as shown in the formula, 3H around the first C, 2H around the second, and 1H on the O. 3. Draw single bonds between the central atom and each terminal atom. Next, let's hook all the atoms together with single bonds. This process uses up 2, 4, 6, 8, 10, 12, 14, 16 electrons, with 2 electrons used in each bond. 4. Distribute the remaining electrons to the outer atoms. We have 20 electrons total to place, and we've used 16 so far, so we need to place 4 more electrons. The outer atoms are all hydrogen, so they can't take them. 5. Assign any remaining electrons. Since none of the hydrogens can take the remaining 4 electrons, and both carbons are surrounded by 4 bonds each, only oxygen has room to take them. Let's add them as 2 lone pairs of electrons here, 2 and 4. 6. Move lone pairs to create multiple bonds if the central atom has less than an octet. All of these central atoms, in this case, the 2 carbons and 1 hydrogen, have their octets satisfied. Take a minute to verify this for yourself. All right, let's clean up this structure and verify that it is correct. Step 7. Verify duets, octets, and the total number of valence electrons. We verified the octets in the last step. Every hydrogen has a single bond, so their duets are satisfied. Counting total electrons, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. This structure is done. We can also build structures for polyatomic ions using the same method if we keep in mind that a negative charge will add an electron, while a positive charge will subtract an electron. We emphasize the presence of this charge by enclosing the entire structure in brackets with the overall charge indicated outside the brackets. Let's look at an example. Let's build the Lewis structure for the polyatomic ion chlorite. 1. Sum up the valence electrons. We have 1 chlorine with 7 electrons and 2 oxygens with 6 electrons each. Chlorite also has a negative charge, so we add 1 electron for a total of 20 valence electrons to place in this structure. 2. Select a central atom and arrange the other atoms around it. From the formula's clues, it's a solid guess that chlorine is going to be the central atom since it appears first. As we continue building Lewis structures, we'll also see that building symmetrical molecules and ions is also a clue to the ideal structure. Chlorine may not be the apparent choice for a central atom. After all, it's only short 1 electron, so it should only make 1 bond. Welcome to the land of exceptions. We'll see that several of the polyatomic ions with a halide as the central atom will violate the octet rule. For now, let's keep working through this example. We'll discuss more exceptions in future lectures. 3. Draw single bonds between the central atom and each terminal atom. Connecting the atoms together with single bonds uses up 4 electrons. 4. Distribute the remaining electrons to the outer atoms. We have 20 electrons total to place, and we've used 4 so far, so we need to place 16 more electrons. The outer atoms get lone pairs first, so here goes the 2, 4 in bonds, then 6, 8, 10, 12, 14, 16. We still need to place 4 more electrons. 5. Assign any remaining electrons. Chlorine only has 4 electrons around it in the 2 single bonds, so let's add the 2 lone pairs here to give chlorine a total of 2, 4, 6, 8 electrons. 6. Move lone pairs to create multiple bonds if the central atom has less than an octet. We just satisfied the octet for chlorine, and both oxygens also have octets. Take a minute to verify this for yourself, then let's clean this structure up to verify that it is correct. 7. Verify duets, octets, and the total number of valence electrons. We satisfied octets in an earlier step. Counting total electrons, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. This structure is done. As always, I'll leave you with the parting thoughts of the authors.